Hey there guys. In this video we're going to be talking about the puzzling case of flight 6 times 10 to the 23. So this is Mole Airlines flight 1023. This is an activity where we're going to do a puzzle together. Everybody's going to have their responsibilities. So let's look at the roles here. Now this is for just first period. Alright, so what I have here is a list of students in our class. This is again for 1A. And then these are the assigned duties. Alright, so there's two tasks that I need each student to do. The first one is to identify compounds. And these are different difficulties, and I've tried to assign them based on what I think you guys can do, and I'll certainly be able to help. Some of you guys are going to identify compound 1, found at the explosion site. Some people are going to find compound 2 on victim 1, found in their luggage, and so on. So in order to get credit for this, you have got to complete assigned duty number 1 and assigned duty number 2. Assigned duty number 2 is to identify the victim. All right, so you're going to tell me who victim number 1 is based on the flight manifest. Okay, and then there's only 8 victims, and so there'll be other people in the class that are also identifying the same victim. You guys can work together. For example, Awesome is going to be identifying victim number 1. So is Diego. So is Jalen and Hunter. So you guys can work together. And then same thing here. Awesome is going to be identifying compound number 1 found at the explosion site. So is Jet and Sandra and Hunter and McCall. Okay, so you can kind of see who you can pair up with. So that's the two things that I need y'all to do, is to kind of participate in this activity. It's not that hard, and I'll help you solve the, identifying the compounds. Identifying the victim is more of just a puzzle. It's just, what is the substance, where was it found, and then kind of piecing it together. Assigned duty 2 is to find the victim, identify the victim. Who is victim number 1, and then these are just going to be like who blew up the plane. So like if you think you know who blew up the plane, like Kasha, if you have an idea based on your results, you can say, okay, I think I know who blew up the plane. We'll type it here, and then we can look and see what everybody thinks. Who was murdered? Remember, there was somebody murdered before the plane crashed, and then who was the killer? Okay. All right. So let's talk about the story here. This is really cool. All right, I didn't do this last year, and I wish I had, so this will be interesting doing it virtually. But everybody's going to have to participate, and if someone doesn't participate, then I'm going to ask somebody else to take over their job if we need to. That's why I assign several students to a job, maybe 3 or 4 students to a job, so that we can make sure it gets done. All right, so let's look and see what we got here. All right, so 6:02 a.m., you and your team of medical examiners, which is going to be everybody in our class, we are called to the scene of an airplane crash in a remote location. The plane shows evidence of a pre-crash explosion. 10 victims are found at the scene, but none are identifiable by witnesses or by dental records or by DNA evidence. So maybe this flight crashed before DNA evidence was a thing. So maybe this is like in the 90s or 80s or 70s, before DNA became to where we could use DNA to identify victims. Okay. One victim was murdered prior to the plane crash. All right, so the medical examiner studied these bodies, and one of them was found to be murdered by some kind of substance. We don't know what substance they were murdered by, but one victim on the plane crash was murdered before the crash. So we can see wounds from the crash and from the impact on this victim, but we can also tell that this victim died before the plane crash and was already dead before the plane crash due to some kind of poison or something. Okay. The flight manifest shows the names and some information about the victims. Okay. Part 1, the plane itself. So here's some evidence from the plane crash. Here is the evidence that's from the plane. A section of the plane has been blown apart by an explosion. It appears as if this explosion happened before the crash. And we can click here to see the analysis of the compounds sampled from the area of the explosion. So if you are assigned compound number 1, this is your compound, okay? So I have a few students that will need to identify this compound. Residue from the explosion site shows the following elemental analysis. So here's the percent composition for each element. This particular compound that was found at the explosion site has carbon, hydrogen, nitrogen, and oxygen. And so let's go ahead and work through this one together and see if we can find what this compound is. And now I'm not going to identify the compound, but I am going to help you guys find the formula. So let's do that. First thing we're going to do with this information is we are going to take the percentages and really just cross them out and turn it to grams. So 37.01 grams of carbon, 22.22 grams of hydrogen, 18.5 grams of nitrogen, 42.27 grams of oxygen. All right, so let's grab this information here. And let's go ahead and find our empirical formula. This activity, by the way, is all empirical formulas, no molecular formulas, okay? So let's try this again. I just want these numbers here. There we go. Okay, so what I'm going to do here is we're going to, again, turn these to grams. So that's carbon. Let me see. This one's hydrogen. Next one's nitrogen. Next one's oxygen. Okay. Nitrogen and oxygen. Okay. Maybe there's a better way to do this. Let me just do a whiteboard. Okay. Let's see. Let's close that. Okay. Let's just do a whiteboard. And I'm going to move the other stuff to another screen. All right. Let's see. So there we go. Let's move that there. Okay. So sorry about that. So we got 37.01 grams of carbon. We're going to divide that by the molar mass of carbon, which is 12.011 grams and 1 mole. And we're going to basically divide by the atomic mass, and that's going to tell us how many moles of carbon we have. This gives us 3.082 moles of carbon. We're going to need to do this for each element. Take the mass of each element, divide by its molar mass. All right, 2.22 grams of hydrogen. That's going to be 1.008 grams of hydrogen in 1 mole. That's going to give us 2.2024 moles of hydrogen. All right, we got 2 elements left. We got 18.5 grams of nitrogen. I'm going to divide that by 14.007 grams from the periodic table. Notice that I'm making sure to be careful not to round the numbers from the periodic table, and that's because I want this to be accurate. And so here we get 1.3208 moles of nitrogen. All right, last one is 42.27 grams of oxygen. And we're going to divide that by 16 grams of oxygen, which is the molar mass of oxygen. And the result there is going to give us 2.642 moles of oxygen. I'm running out of room here. Okay, so let me double check my numbers. Everything looks good. That looks like a comma, but that's a period, a decimal. Okay, so we're going to look at these 4 numbers. And which one's the smallest? Looks like this one's the smallest. Right? So we're going to divide all of them by that small number. Divide by 1.3208. Divide by 1.3208. Divide by 1.3208. Divide by 1.3208. Let's see what we get. And part of the reason I'm doing this one is because it gives us something weird. We end up with 2.33 carbon atoms. We end up with 1.667 hydrogen atoms, 1 nitrogen atom, and 2 oxygen atoms. Okay, so we got 2.33 carbon, 1.67 hydrogen, 1 nitrogen, and 2 oxygens. So what I'm going to do is I'm going to clean the screen, but we're going to keep the numbers that I just grabbed, okay? So, and then we're going to determine what the formula is. Okay, so I'm going to rewrite what we just had. 2.33 atoms of carbon, 1.667 atoms of hydrogen, 1 atom of nitrogen, and 2 atoms of oxygen. Okay, so this is an interesting empirical formula. We end up with these numbers, like I've been saying in the notes, we have to get whole numbers, okay? But there are instances where you don't get whole numbers. But there is a trick, an easy trick that we can do here to get whole numbers. What I can do is think about a number that I can multiply all of these by and kind of double or triple or quadruple the formula and then end up with whole numbers. So I got a 0.33, which is about a third of 1. It's about a third, right? 0.33 is equal to 1/3. So if I multiply all of these by 3, I can probably get whole numbers. And it is kind of tricky to figure out that you need to multiply by a 3, but if you try multiplying all 4 of these number of atoms of each element by that 3 and see if you get whole numbers. When I do this, I get a 7. So 2.33 times 3 gives me a 7. This one gives me a 5. And they're not going to be exactly 7 or exactly 5, but they're really, really close. All right, this is going to give me 3, and this is going to give me 6. All right, so let's write our formula. Let me clean this here. I need some room to write the formula. So let's write the formula, and then I'll have you guys identify it. C7H5N3O6. All right, that's our formula. Excuse me. All right, so if your job is to identify compound 1 found at the explosion site, take a look. Let's see if I can make this smaller without closing it. There we go. Let's make it smaller. There we go. C7H5N3O6. We're going to go ahead and look at the list of possible compounds. Here we go. Let's see if I can get this one back up. All right, C7H5N3O6. That is the formula of what we just found. Peruse this list and find your compound. Okay, so if you're identifying substance 1, just find the formula there and then look at the list of possible compounds. It tells you the name of the substance and what it is. So this one is dimetresine, and it's an antidepressant. Acetaminophen is basically aspirin. Nitroglycerin. Nitroglycerin is used as an explosive or heart medication. So you got to think about where it's found in order to determine whether it was used as an explosive or heart medication. Thiobromine is in chocolate. Vanillin is vanilla. Codeine is a prescription painkiller. Trinitrotoluene explosive. So this one's unexplosive only. So if you find this one, it is only from the explosion. Okay. Curare is a poison. Strychnine is rat poison. Cocaine is a narcotic drug. Aspartame is an artificial sweetener. It's in diet drinks. Aspirin is kind of like acetaminophen. It's a painkiller and blood thinner. Chloroform is a knockout drug. Diazepam is a minor tranquilizer. It's a type of Valium. Formaldehyde is plant and animal preservative. Lysergic acid. This is LHD. This is a narcotic. It's an illegal. This is basically acid. Okay, so this is trying to think of the name of it. LCD. Drawing a blank here. Lysergic acid. LSD. There you go. Sorry. LSD. That's what that is. Okay. And then this one is polyamine, which is an antihistamine. Okay. Which is used to treat allergies and stuff. Okay. So identify that substance. All right. Let's go back to our compounds and look here. Okay. So let's continue here. Okay. So we talked about that. So this is compound number 1 for the at the explosion site. Let's go ahead and look at the flight manifest. Okay. So these are all the people on board. First one is red Tukrok. He's an American pilot with a secret heart condition. T. King Bomba is a Colombian political leader and suspected terrorist. All right, B. N. Klaas is a German retired teacher that's addicted to diet drinks. Miss Ivana B. Down is an American unemployed environmental engineer, avid environmentalist, and has had a reoccurring problem with depression. Isabella Ubai is a South African, an independent contractor, suspected drug dealer. All right, Through It All Away is an American pro athlete just suspended for addiction to over-the-counter pain medication drugs. All right, Pierre E. Claire is a French baker. Rebecca A. Pillseller is a Canadian pharmacist. Ivana Killet is a Swedish world-renowned big game huntress. And Imsum Kwat is a Japanese psychiatrist. All right, so we can return to the plane here. We can click to see evidence from the plane. So we already looked at this one. So let's go ahead and look at evidence from victim 1. So these two compounds, compound number 2 and compound number 3, need to be identified. And they're both found with victim 1, which we need to identify. And these are both found in the luggage. Okay, so we're going to do the same thing here. Same thing here. Let me look at compound 2. Compound 2 is really easy. So I don't need to tell you guys anything with compound 2. Compound 3 is really easy as well. But these are both interesting compounds, so if you get to identify compound 2 and 3, that'll be interesting. And then you can identify victim number 1. You can tell who he is based on the flight manifest. Okay, next slide is let's look at victim number 2. Okay, victim number 2, compound number 4. So you're going to divide the mass, the 63.15 grams of carbon, by the molar mass of carbon. Do this one divided by hydrogen, this one divided by oxygen. When you get your moles, you're going to not get a whole number, okay? So for example, when you do this one, you're going to get 2.667 carbon atoms and 2.667 hydrogen atoms, okay? So they're not whole numbers. You got to make them whole numbers. And all you got to do is multiply this by 3. So that should give you 8 carbons and 8 hydrogens, and then 3 oxygens. So your compound is C3H8O3. So I wanted to help you out with that one. C8. C8H8O3. There's that formula for compound 4. All right, let's check out compound 5. Compound 5 is also tricky. You're going to end up with 3.5 carbon atoms, 4 hydrogen atoms, 2 nitrogen atoms, 1 oxygen atom. And what you're going to do is multiply them all by 2. Okay, and then that's going to give you 7 carbons, 8 hydrogens, 4 nitrogens, and 2 oxygens. So from that, you should be able to determine the formula and this identity of the substance. And then these two compounds both belong to victim number 2. And it was found, compound number 4, this one, found on the clothes and in the briefcase of the victim. Compound number 5 was found in the stomach. All right, let's look at victim number 3. Man, this is cool. Compound 6. So both of these compounds were found with victim number 3. Okay. Compound number 6 is really simple. You're going to divide each of the masses here by the molar mass. Divide this one by 12, divide this one by 1, divide this one by 16, divide this one by 14. You'll get a number. Figure out which number of those. You get a number for each of these divisions. Excuse me. Figure out which one is the smallest. Divide them all to the smallest. You get your formula. All right. Compound number 7 is also very easy. Same thing. Divide this mass of carbon by 12. Divide this by 1. Divide this by 16. Divide this by 14. All right. Compound number 6, right here, was found in the pocket, and there's 2,000 tablets of this substance found in the pockets of the victim. Compound number 7 was found in the blood of victim number 3. All right. Victim number 4. There's 8 victims. All right. There's only one compound found on victim number 4. This one is a little tricky. You're going to take each of these divide by the mass. So you're going to divide that by 12, divide that by 1, divide that by 16, divide that by 14. What you're going to end up getting is 1.32 moles of carbon, 2.2 moles of hydrogen, 3.96 moles of oxygen, and 1.32 moles of nitrogen. All right, and what you're going to do is multiply all of these numbers by 3. All right, and so what you're going to get there is going to be 3 carbons, 5 hydrogens, 9 oxygens, and 3 nitrogens. So that should tell you what the formula is. Again, this compound was found in the pockets and in the blood of victim number 4. This is compound number 8. All right, let's go to victim number 5. All right, both of these compounds were found on victim number 5. This one was found in the blood. This one was found in the suitcase, or clothing and luggage. This one's interesting. You're going to divide this by 12, by 1, by 16, and by 14. You're going to get 10.5 moles of carbon, 11 moles of hydrogen, 10 moles of oxygen, and 1 mole of nitrogen. And what you're going to need to do is multiply all of these by 2. All right, and what that's going to give you is 21 carbons, 22 hydrogens, 20 oxygens, and 2 nitrogens. All right, so identify what that one is. This one was found in the blood of victim number 5. Compound number 10, you're going to get 2.33 for carbon, 1.67 for hydrogen, and then basically you're going to get 2 for oxygen and 1 for nitrogen. Multiply them by 3. So everything needs to be multiplied by 3 here. Okay, and that'll give you your formula. This one's going to be 7 carbons, 5 hydrogens, 6 oxygens, and 3 nitrogens. Okay, that's victim number 5. Let's look at victim number 6. And I'll give you guys the link for this video so that you guys can kind of skip around and try to identify your victim. This is compound 11. It's found on victim number 6. It was found in the briefcase and the pockets. This one looks really simple, so nothing crazy here. Divide the carbon by 12, divide the hydrogen by 1, oxygen by 16, and nitrogen by 14. Get your certain number of moles for each of these elements, and then divide all of them by the smallest number to get your formula. All right, so pretty easy for compound number 6. Let's look at or compound number 11 on victim number 6. Let's look at victim number 7. 2 compounds found on victim number 7. Compound number 12 and 13. Compound 12 is really easy. Divide this by 12, divide that by 1, divide that by 14. Figure out the formula. And compound 13, you're going to get 10.5 for carbon, 11 for hydrogen, 1 for nitrogen, and 1 for oxygen. And you need to multiply them by a 2 to get whole numbers. Okay, so 10.5 times 2 will be your number of carbon. 11 times 2 will be your number of hydrogens, and so on. All right. This one was found in the briefcase of the victim. Compound 12 was found in the pockets and in the blood of victim number 7. Compound 13 was found in the briefcase of victim number 7. All right, last victim. Victim number 8 had 2 compounds on him. Compound 14 and 15. Compound 14 is real easy. Divide this by 12, by 1, by 14. This one you divide by 35. This compound was found in the pockets of the victim. Compound 15 is pretty simple. Divide this by 12, by 1, by 16, and by 14. And you can find the formula for that. This one was found in the briefcase of the victim. All right. Oh, I thought there was only 8 victims. Maybe there's 9. Let's look at 9. I didn't even know there was 9. I thought there was only 8. Oops. Let's look at victim number 9. Oh, compound. Okay. So compound 16 and compound 17. We're going to need to do these two. All right. Let's start with compound. I don't want to do these. We'll do these in class. Well, let's do it. All right, compound 16 and 17. We got to figure out what the formula for these two are. We're going to do these together. Okay. So let's move my presentation over there. All right, and let's identify compound this is gonna be compound 16. All right, we'll do this one together. I'll try to do it quick. So if you're interested in compound 16, pay attention. If not, then this doesn't really apply to you. So 10.06 grams of carbon, 0.85 grams of hydrogen, 89.09 grams of chlorine. I'm going to divide that one by 12.011. Going to divide this one 1.008. We're going to divide this one by 35.453. All right, let me get my calculator and knock these out. 10.06 divided by 12.011 gives us 0.8376. That's moles of carbon. 0.85 divided by 1.008 gives me 0.8433 moles of hydrogen. Notice that those numbers are close to each other, so that's a 1-to-1 ratio. 89.09 divided by 35.453. That's a decimal there. That's going to be 2.513. So there's a lot more chlorine than the other two elements. All right, so we're going to divide all three of these numbers by the smallest. The smallest is 0.8376. Okay. That's going to give me 1 carbon. 0.8433 divided by 0.8376. That's going to be 1 hydrogen. 2.513 divided by 0.8376. That's 3 chlorines. So CHCl3. All right, and then we'll identify this one. Let's look at our list of compounds. CHCl3. This is found on victim number 9. Found in the luggage. All right. This is chloroform. This is the knockout drug. So this is a drug, a compound that is typically used to you soak it in a rag and put it on someone's face and then they pass out. So this is a knockout drug, chloroform. So that is not good. Okay, let's identify this compound here. If you guys can see what I'm doing, this compound here. This is going to be compound number 17. Let's figure out what this one is. All right, let's do it. We got 39.99 grams of carbon. We're going to divide that by 12.011. We're going to take the 6.73 grams of hydrogen divided by 1.008. We're we're going to take the 52.28 grams of oxygen. That's the last one. We're going to divide that by 16 grams of oxygen and 1 mole. All right, so 39.99 divided by 12.011 gives us 3.3294 moles of carbon. 6.73 divided by 1.008 gives me 6.6746 moles of hydrogen. Notice that I'm not rounding much. I would round to 4 digits, maybe 5, but no more, no less, okay? So 4 or 5 digits is just fine. 52.28 divided by 16 gives me 3.2675 moles of oxygen. The smallest number here is the 3.26. We divide all of them by that smallest number. 3.3294 divided by 3.2675. That gives me 1 carbon. 6.6746 divided by 3.2675. That looks like, whoa, hold on. 6.6746 divided by 3.2675. 2 hydrogens. So 1 carbon, 2 hydrogens, and this is 1 oxygen. So CH2O. CH2O. Let's figure out what that is. CH2O. 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 Oh, formaldehyde. Plant and animal preservative. Okay. So this compound was found on victim number 9 and the luggage. Formaldehyde. Chloroform and formaldehyde. Trying to figure out who victim number 9 could be. They're both found in the luggage. Let's look at the flight manifest. Got an idea. Formaldehyde. Okay. Okay, I think I know who that is. Okay. Let's look at compound number 10, or victim number 10. And again, if you're not doing victim number 10, then you can skip this unless you want to see more examples of how to do these. So I'm going to do victim number 10. This is going to be compound 18 and 19. Ooh, it's a lot of compounds. So let's move this over. All right, let's do this one. All right, 67.48 grams of carbon, 5.62 grams of oxygen, 4.61 grams of hydrogen, and 12.45 grams of chlorine. So 35.453. Okay, let's divide these out. 67.48 divided by 12.011, 5.618 moles of carbon. 5.62 divided by 16, it's going to be 0.351 moles of oxygen. 4.61 divided by 1.008, 4.573 moles of hydrogen. 12.45 divided by 35.453, and I get 0.351 moles of chlorine. Okay, so we're going to divide by the smallest number, which is 0.351. We can see that there's 1 atom of oxygen, and 1 mole of chlorine. So I'm going to do 5.618 divided by 0.351. I got 16 carbons. I got 1 oxygen. I got 13 hydrogens and 1 chlorine. So we got C16. Let me get a different marker so it's a little clearer. C16H13OCl. What the heck is that? Let's see what that is. C16H13 C16H13. Oh, I didn't do the nitrogen. Was there nitrogen in that compound? One second, guys. Was there nitrogen in this compound? This is victim number 9. No, this is victim number 10. Oh, there's nitrogen. 9.84 nitrogen. Let's see the nitrogen. So 9.84 divided by 14.007. That gives me then 0.351. Okay, I got 2 nitrogens. Okay, my bad. So 2 nitrogens. So that's this one. Diazepam, tranquilizer. So minor tranquilizer, Valium. Okay, let's find out victim 10. All right, let's look at our last compound. All right, we're going to do this one right here. All right, let's figure out what that is. This one is 81.58 grams of carbon, 8.9 grams of hydrogen, and 9.52 grams of nitrogen. We're going to divide each of them by their molar mass. 81.58 divided by 12.011, 6.792 for carbon, 8.9 divided by 1.008, that's 8.83, and then 9.52 divided by 14.007 gives me 67.9. Wait, no, that's not right. Let me try that again. 9.52 divided by 14.007. 0.6797. Okay, so the smallest number is at 0.6797. 6797. 6797. All right, let's divide these out. I get 10 carbons. Oops, 8.83 divided by 0.6797. I get 13 hydrogens and 1 nitrogen. So that becomes, I can give myself some room, C10H13N. Let's see what that one is. All right, maybe we can identify victim number 10. C10H13 and 1 nitrogen. See what we got. C10H13. Anybody see it? There it is. Antidepressant. Okay, so antidepressant and diazepam, minor tranquilizer, found on victim number 10. All right, let's look back at our flight manifest. Okay, let's see here. Flight manifest. Okay, gonna have to think about this, but I think I finally I identified all 10 victims. I've got 8 down really good, but doing these last 2 compounds, which I haven't done yet until just now, doing these last 2 compounds helps us figure out the last 2 victims. All right, so again, make sure you guys look at the list of tasks, assigned duties, and just do your 2 tasks. Stick around if you want to see who was killed, who was the killer, and all that kind of stuff. I wanted to do something kind of fun this week because it's Star Week. We've been doing lots of notes and stuff, and this is a really cool activity, so hopefully you guys like it. It's been fun kind of preparing to do it, and I hope we're engaged and we can do it. And if you need help with doing the empirical formulas, I'll help you. That's no problem. If you want to review, we can review, but I think we're going to go ahead and have our test pretty much our next day of class, which, let's see, Wednesday is going to be a half day, so we won't have a test Wednesday unless we have enough time. So it could be on Wednesday. If not, then it'll be the next day of class, which might be Friday. All right, so we could have a test on Friday. All right, guys, thank you. Have a good one.